Alright, I got a request to make a video for standard 3 of this unit, which has to do with scale factors, basically, similar figures. Alright, I'm going to show you this chart, I'm going to explain the chart, and then I'm going to use the chart. So, this chart, a lot of people say it's helpful, so maybe you will find it helpful as well. Here's what the chart looks like. Every figure has dimensions. Those dimensions, when I change them, right, so like let's say I had an old figure, I change it by a scale factor, and that gives me a new figure. So when I change those things on a figure, I end up changing the area. When I change the dimensions, I also change the volume, right? When I change the dimensions, I change the area. When I change the dimensions, I change the volume. When I change the dimensions, I have a scale factor. When I change the dimensions, the area changes by that same scale factor squared. When I change the dimensions, that volume changes by that same scale factor cubed. This is what the chart looks like. Now I'm going to explain why this happens. So take a picture of this, write it down, and then I'm going to explain it. Done. You wrote it down. Now, let's explain how this works. So, if I have a cube here, yeah, don't make fun of my drawing, but I have a cube, and let's say I have dimensions of a length, a width, and a depth, right? And I actually triple those dimensions, so now I have a bigger cube. So if I triple the dimensions, this is actually 3 with a depth of 3. Alright, so like I said, when I changed the dimensions, I had my old dimensions as 1, and then I tripled them, so my new dimensions are 3. The scale factor between them is obviously 3. How much does my area change if I triple all of my dimensions? All of my dimensions are tripled. Well, the surface area changes by that same scale factor squared. So my volume changes by that same scale factor cubed. 3 cubed is 27. Alright? The reason why this chart makes sense to me, at least, is because if I was given, let's say, a sphere looks like this. And then I had a bigger sphere that looks like this. If I told you my radius here was 1 and my radius here was 3, I want to know what the surface area is here and what the surface area is here. Well, the surface area, I believe, is yeah, that was me running across the room to grab a chart. Surface area of a sphere is 4 pi r squared. This is the formula, 4 pi r squared. 4 pi r squared. So I have 4 times pi times my radius squared. 4 times pi and my radius squared. If you look at 4 times 1, I get 4 pi. If I do 4 times 9, I get 36 pi. So my radius changed by a scale factor of 3, then that means my surface area better have changed by a scale factor of 9. So did it? Let's check. 36 pi divided by 4 pi better equal 9. I'll say that one more time. My radius changed. It tripled by a scale factor of 3. My volume changed by a scale factor of 9. That's my proof to show you that in my chart I have dimensions with a scale factor. The area will change by a scale factor squared, and my volume will change by that same scale factor cubed. Now this only works if all of my dimensions change with the same scale factor. All of my dimensions have to change by the same scale factor. So like your epsilon questions will say, my radius was 1, my height was 4, my radius doubled, but my height stayed the same. Alright, there's 2 different dimensions here, but only one of them doubled. So that means this chart won't work. This is the exception. If I change one dimension but don't change the other, then this chart will not work. I'm going to say that again. If one dimension changes but the other one doesn't, then this chart will not work. Alright? Now, that's kind of the gist of it. If you have more questions, ask me specifically.